Okay, so suppose to understand titration, we'll take an example, and we'll take a simple reaction: acid plus base gives salt plus water. This type of reaction you have seen earlier, right? Salt plus
Yes,
water.
so
So this is let's say HCl solution plus NaOH aqueous. Whenever you write aqueous, that means it is dissolved in water. Gives
yeah.
NaCl aqueous plus water. Okay. So let's see how we will do this. We don't know the concentration of this. Concentration of HCl is unknown. Okay. And you have a standard solution of this, say 1 molar solution of this. 1 molar solution of this. Now you want to find out concentration of HCl. Now the way you do it is, let's say you have V milliliters of solution here, V milliliters of solution here. Then you will take a tiny amount, like you will keep the HCl solution in this container, HCl solution here, and then you will drop NaCl, NaOH solution, or you will mix them somehow. The experimental arrangement can be whatever is more convenient. You will drop NaCl, NaOH from here, drop by drop. In a very graded manner you have to drop, because what you want to track is when does HCl completely react. All of the HCl reacts. Okay, that point you have to figure out. Okay, so you can keep an indicator or a litmus paper or something here, right? Litmus paper, which will keep telling you what is the pH of this solution, or whether it is acidic or basic right now, right? Right. So as you drop a NaOH into it, what happens is this reaction keeps happening, right? And the HCl is consumed, right? As you drop NaOH, HCl is going to be consumed, and slowly the pH will start to rise, right? pH will start to rise. So you know that pH of acidic medium is less than 7 and basic medium is greater than 7 for acidic, and for basic compounds its pH is greater than 7, and pH is equal to 7 when you are neutral, right? You know this, right? So what I will do is, drop by drop I will add NaOH slowly, and I will keep seeing the litmus paper, right? So what will happen is, because you know the concentration of NaOH, you exactly know how much NaOH you have added, right? Because that container, right, will have some readings. No, you can check how much volume you have dropped, right? Correct. So at some point what will happen is, pH litmus paper will turn red to blue or whatever. It will start just turn red to blue, right? So that means it was like 1 drop ago it was still acidic, right? And if you added 1 drop now, it became basic, right? You understand? So you have to keep track of that to a fine degree of precision, where just before it was acidic and now you added 1 drop, it has changed the color, right? So that means just now it has crossed pH 7, right? So that means now you know that how much of NaOH was added. You know why milliliter of NaOH was added when pH was 7, right? When pH was 7. Okay. So that means why ml of NaOH completely neutralize the HCl present there inside, right? Correct. So why ml was needed to completely titrate it? This is called titration of HCl, right? So why ml was needed to titrate it? That means now you know how much of NaOH was there, right? How much of NaOH was needed, right? So y ml into 1 mole per liter, right? So that means y by 1000 mole, right?
Yeah.
Y by 1000 mole, that means y, we can write it as millimole, right? Milliliter into mole is millimole, right?
Yeah.
Correct. Milliliter by liter into mole. So why millimole of NaOH was needed to completely react with HCl? And from the balanced equation, we know that they react in 1:1 ratio, right?
Yeah.
So that means this had Y millimole of
It's
HCl, right?
hmm.
Correct. And
Yeah.
and
Yeah.
originally the volume of the solution was V, right?
Yeah.
V ml of the solution was there, no?
Yeah. Yeah.
So, and that had Y millimole of HCl. That means Y by V is the millimole by milliliter. So that becomes Y by V is the molarity of HCl. You understand?
Yeah.
So titration is basically keeping track of how much volume of a known standard solution is needed to completely react with an unknown solution. If you know how much volume was needed to completely react with this, you will have a sense of how much of the compound in moles was needed to completely react with this. And that will tell you how much of this was present to start off with, right?
Yeah.
Once you get a sense of how much HCl was present to start off with in moles, then you can divide by the initial volume of the HCl to get the concentration of the HCl, right? So this is a standard method to find out the concentration of an unknown substance by using a known concentration standard solution, right? And some reaction between the two, right?
Yeah.
So that is the meaning of titration. We'll come to some questions and then it will be more clear. Uh, let's see, titration is 3.9. 3.10 is percentage composition and empirical formulas, right? Uh, let's see that. 3.10. This empirical formula stuff you have seen before in class 9th and 10th. Have you ever seen this before? No, nobody has seen this.
So
Okay, so it is there in ICSE, that's why I'm asking. Okay, so let's just look at it. How to find molecular formulas? Find molecular formulas and empirical formulas. Empirical, what is the meaning of the word empirical? Does anybody know? Empirical means experimental, based on experiment, right? So uh, based on experiment. So empirical evidence, for example, means you just took 2-3 cases and saw what happened. 2-3 cases, the results is an empirical evidence. So that is not convincing in the sense that it is not the final word on it, but it is just some evidence for it. So empirical formula would be you tried to do an experiment and figured out what ratios some things reacted, some compounds reacted, and from there you are making a guess at the molecular formula. Empirical formula is based on the reaction that you saw. What is the formula? So we'll do one
yeah.
question and it will be clear. So let's look at worked example 3.15, which is vitamin C. So vitamin C contains 40.92% of carbon. 40.92% of carbon. It has 54.5% of oxygen and 4.5%. 54.5% of oxygen and 4.5% of hydrogen by mass. This is vitamin C. And what is the empirical formula of vitamin C? Empirical formula is being asked. Okay. So basically, tentatively from this data, this experiment, what would you guess to be the formula of vitamin C? Okay. So the way we do it is, let's try to figure out. So we basically do unitary method. Okay, so if you have 100 grams of vitamin C, right, how many grams are carbon?
40 plus.
54.5 grams of oxygen and
Yeah.
4.5 grams of hydrogen, right?
Yeah.
So let's make a table. 100-gram vitamin C is here, carbon is here, hydrogen is here, oxygen is here, and this is 40.92 gram, this is 4.5 gram, and this is 54.5 gram, right?
Yeah.
Okay, so now how many moles are there? 100 gram of vitamin C seems to have how many moles of how many moles of carbon? 40.92 divided by 12, right? And this is
Yeah.
4.5 by 1, and this is 54.5 by 16, right?
Yeah.
These are the moles, right? Mole.
Yeah.
Okay. So let's do an approximate calculation. 40 by 12 will be almost 20 by 6, so 10 by 3, so 3.33. So let's say 3.33, and 0.92 by 12 would be around 6, so 3.39 maybe. Let's say 3.39 or 3.4. Let's go for 3.4. 3.4 into 12 is out 36, and 0.4 into 12 4.8, so almost close. Yeah, this is the moles, and this is 4.5 moles, and this divided by the 3.65, so 6 is almost 4. Okay, so this is also close to 3.4, no?
Yeah.
I think 16 into 3 48, 16 for 66.4, so 48 plus 6 is 54. This is close to 3.4, right?
Yeah.
So you get this. Now the problem is that this is 3.4, 3.4, and this is 4.5, right? So if you divide by the lowest one, you're getting 1. So divide by, so we are trying to get the ratio of C, H, and O, okay? Then only you will be able to write the formula, no?
Yeah.
We are trying to get the ratio of C, H, and O here. So 3.4, 3.4 is nice because you can divide by 3.4, you'll get this.
Yeah.
4, and this is 1, right? Correct.
Yeah.
Yeah.
So 45 by 34 approximately uh, is almost 45 by 35, which is 9 by 7. 9 by 7 is 1.26 is 8, 1.28 almost. So 1.27, I will say 1.27. So 1 is to 1.27 is to 1 is the number of mole ratio, right? Correct.
Yeah.
So what we want is to have integers. No, you cannot have 1.27 atoms of H, right?
Yeah.
So you want to multiply it with such a number that all of them become integers, right? All of them
Yeah.
should be integers. So 1.27, how many times will you multiply to make it close to an integer at least? If you do 8 times or 7 times, what happens? 7 into 12, 1.27. 7 into 127 is how much? 128, 40, 7 7 49, 869. Not very close to integers. 8 times if you do, 8 into 12 is 96, 1960, and 7 8 is a 56, 1016, right? Okay, so that is close to it. It will become 10.16 or something if you multiply by 8, right?
Yeah.
So that is quite close to an integer. So 8 times I'll multiply 8, 8, right? Right. So my empirical formula, because I have done many of the calculations approximately, okay, in my head I've done. You can use a calculator and do it, then it will be more accurate. My empirical formula is C8H10O8.
Yeah.
You understand?
Yeah. Yeah.
I have first gotten the ratio, first gotten the moles, then I have gotten the ratio of the moles, and the ratio of the moles was coming like this, and made it integers, made all of them integers, right? By multiplying some fractions, right? So
Yeah.
my guess is C8H10O8. Now let's see the book what they did. Oh, 343 is also working. Okay, I forgot to check that. So his ratio is coming 1 is to 1.33 is to 1. Okay, my calculation was slightly wrong here. That's why. If I had done the calculation properly here, 1.33, I would have multiplied by 3, no?
Yeah.
You
Yeah.
understand? I got 1.27, so I was going for big numbers. But if I had gotten accurately 1.33, then it's very peaceful. I'll just multiply by 3, and this becomes 4, and this becomes 3, right?
Yeah.
You
Yeah.
understand? So this sort of a formula that you're guessing it based on the percentage composition of a substance and the mole ratios that you're getting from there. Once you are guessing this formula is called an empirical formula. Okay, this is not necessarily the real formula. It could be, instead of being C3H4O3, it could also be C6H8O6, right?
Yeah.
Right. It could also be C9H12O9, right?
Yeah.
All of these are things that will satisfy the same ratio, no?
Yeah.
You understand? Like many
Yeah.
infinite possible formulas are there which will satisfy the same ratio, right? So now, if someone tells me that the molecular weight of ascorbic acid or vitamin C is something, right? If someone tells me the molecular weight of ascorbic acid or vitamin C, then you will be able to say that which one of these is correct, right?
Yeah. Yeah.
So empirical formula is not the final word on the matter. It is just the likely formulas are these. And now if you give me additional information like the total molar mass of vitamin C was something, then I will be able to easily see whether this is working or this is working or this is working, right?
Yeah. Yeah.
Correct. So
Yeah.
so that is what is the method to find out the empirical formula. You can also do the opposite process. You can find the percentage composition from a formula. So for example, let's say we have some sugar, we have some compound like C6H12O6. So that is glucose. C6H12O6. This is glucose. And let's say you have to find the percentage composition of glucose by mass, right? So we are
Yeah.
going the opposite way. We are going from here to the final percentage of C, percentage of H and all, right?
Yeah.
So, so let's just take 1 mole of glucose. 1 mole of glucose will be 72 plus 12 plus 16 into 6, 96, right? So it will be
Yeah.
180 grams, right?
Yeah.
84 plus 96, right? 180
Yeah.
grams. In 180 grams, you have 72 grams of C. So 72 by 180 is the percentage of C, and 12 by 180 is the percentage of H, and 96 by 180 is the percentage of O, right? So
Yeah.
this is
Yeah.
fairly straightforward what you have to do, right? Even the opposite thing would have been straightforward. It's just that if percentages are given, then take 100 gram and start from there, right?
Yeah.
You understand how we got the empirical formula in the earlier case. We took 100 gram of substance and we saw how many grams was carbon, how many grams was H, how many grams was O, right?
Yeah.
Then we converted that to moles and we got the ratio of the moles. Once you got the ratio of the moles, you have to ensure that all three elements have integer number of atoms, right?
Yeah.
So you will multiply it by some number to make everyone an integer, right? Correct?
Yeah.
Okay. So cool. So this is this empirical formula and percentage composition and all. Now let's look at the exercises of this chapter. I will just show you a couple of exercises, questions, and I expect you guys to try the questions later after this. Okay. So let's look at. There are all the questions, even number questions you should attempt for sure, because what will happen is the answers are there at the end. Sometimes some
Yeah.
question, the other questions, the answers are not there, so it will be difficult for you to do those. 3.146. Okay, 3.146 question number. Okay, let's look at that. An unidentified metal M reacts with unidentified halogen to form a compound MX2. So M is a metal and X2 is a halogen. Halogen is chlorine, fluorine, bromine, iodine, right?
Yeah. Yeah.
And they
Yeah.
react together to form a compound MX2. Now, MX2, what is happening? MX2 is decomposed on heating to become MX plus X2. So 2MX2 gives MX plus X2. So 2X plus X2. Okay. So this is
Yeah.
the decomposition. Now he's saying when 1.12 gram of MX2 is heated, 1.12 gram of MX2 is heated, 0.72 gram of MX is obtained. 0.72 gram of MX is obtained. Okay. And what else? Along with 56 ml of X2 gas. Along with 56 ml of X2 gas. Now, he has given you this fact. This is a standard fact that under the conditions, 1 mole of the gas has 22.4 liter volume. Under the conditions of the question, under standard temperature and pressure, 1 mole of any gas has volume of 22.4 liters.
22.4.
Okay. So what is
Yeah.
standard temperature and pressure? Standard temperature is 273 Kelvin and standard pressure is 1 atm pressure. If pressure and temperature are fixed, then the volume of 1 mole of any gas will always be 22.4 liter. This is a fact that is there. That is there from gas laws. We will do them later in detail. Right now, don't worry about it. So why has he given you that information? Because volume of the gas is given. So that will give you an estimate of moles of the gas, right?
Oh, yeah.
Yeah.
Right. So 56 ml divided by 22.4 liters is the moles of the gas, right?
Yeah.
Liter per mole, 22.4 liter per mole. So mole will come on top. So this ml and L will cancel and will become millimole, right?
Okay.
You understand?
Yeah.
Yeah.
I am not going to, so it's 1 by 1000 liter mole, no? So millimole, we'll call it millimole. And let's do this. So 56 by 224 is 1 by 4. So 10 by 4 this is, right?
Yeah.
Because 560 by 220, 56 into 4 is 224. So yeah, right? So 10 by 4, so it is 2.5 millimole, right? 2.5 millimole of X2 gas. And what else is there? You have to find atomic mass and identity of X, atomic mass and identity of M. Okay. So all the information that is needed is already given to you. Now, 2.5 millimole of X2 has come out, right? Okay.
Yeah.
And the balanced reaction was this, right? So how many moles of MX2 was used up to create this much? If 2.5 millimoles of gas has come out, how much moles of MX2 must have been reacting? Look at the ratio, the balanced reaction, 2 to 1.
So it's 5 milli.
5 millimole, no? Is that clear?
Yeah.
That should be very clear because the balanced reaction will give you the ratios of the moles that react, no? So if 2.5 here, then 5 must be here, 5 must be here, no?
Yeah.
Correct? Okay, then that just immediately tells you the mass, right?
Yeah.
That immediately tells you molar mass, no? If 5 millimole is weighing 1.12 grams, then 1 millimole weighs 1.12 by 5, and 1 mole weighs 1.12 by 5 into 1000.
2000.
So
Yeah.
this becomes 200. So this becomes 112 into 2, 224 grams,
224.
right?
Yeah.
And
Yeah.
when you do the same thing for this, it becomes 0.72 by 5 into 1000.
Into 1000.
It becomes 200. So it becomes 72 into 2, 144, right?
Yeah.
Right.
Yeah.
So mx has weight 144. So let's say m's weight is small m and x weight is small x. So m plus x is 144 and m
Yeah.
plus 2x is equal to
2x.
224, right? So when you subtract, you get x is equal to 80
Yeah.
Yeah.
and m should be then 64,
Yeah.
right? So now 64 is copper, 63 is copper, 63.5 or something, and x is bromine, 80 is bromine. Okay, so you can check that. So this will be copper and bromine, right?
Yeah.
You understand? From the periodic
Yes.
table, now we can get that, right? So this was a fairly easy question because x2 milliliters was given, and you were given that it is at standard temperature and pressure. So 22.4 liters will be 1 mole, right? So that quickly gave you the idea of how many moles of x2 was going to be there, right? Once you knew moles of x2, you will be able to, by the balanced equation, say how many moles of mx2 and how many moles of mx, right?
Yeah. Yeah.
And once you did that, you will get the molecular mass of each of the two compounds, right? Molar mass you'll get. Everyone followed the steps we took, no? How we got it.
Yeah.
Yeah.
All of the steps are commonsensical steps by just thinking about moles and balanced equations, right? There's no like very big leap of creativity here. Like it's very simple stuff, right?
Yeah.
Okay, let's look at slightly more complicated questions. I will just look for something nicer. Okay. Uh, okay. Okay, let's look at 3.148. 3.148. 3.148 is a titration question. So I want to discuss one of those questions. Okay. So it says element M is prepared industrially by a two-step procedure according to the following unbalanced equations. First equation is M2O3 plus M2O3 plus C plus Cl2 gives MCl3 plus CO plus C plus Cl2 gives MCl3 plus CO. And the second equation is MCl3 plus H2 gives M plus HCl. MCl3 plus H2 gives M plus HCl. Okay. These are the two
Yeah.
equations. These are not balanced right now. Okay. So our first job would be to balance the equations. Okay. Only if you have a balanced equation will you be able to like do anything with it, right? So
Yeah.
let's balance the first one. Carbon is balanced, oxygen is not balanced, so 3 is needed there. Okay, so maybe 2 MCl3 and 3 Cl2. So chlorine is balanced, this is balanced, right? And
Yeah.
oxygen is
Yeah.
3, so make it 3 here and make it 3 here, right?
Yeah.
Now I
Yeah.
think everything is balanced, right? 3CO, M2 is balanced and chlorine is also balanced, right? Correct.
Yeah.
Now here make it 3H2 and 3HCl, I think. 3H2, no. M is balanced, chlorine is 3, so you need 3HCl. Okay, so then 3H2 you need 3 by 2, so
Yeah.
multiply by 2. So 2MCl3
2, 3,
is
2,
becoming 2 plus 6,
Yeah.
right? 2,
Yeah.
3, 2,
Yeah.
6, right? This is balanced, I think. Correct? Yeah.
Yeah.
Okay. Okay. We have balanced our equations. Now we look at the data. Assume that 0.855 grams of M2O3 is submitted to the reaction sequence. So you are giving how much? 0.855 grams of M2O3. Okay. And when the HCl produced in step 2 is dissolved in water, and titrated. Okay, so the HCl produced in step 2 is going to be titrated. Okay, it is going to be first dissolved in water to make a solution, then titrated with some known standard solution. Okay, so known standard solution is what? 0.511 molar NaOH. The standard solution that will be added is 0.511 molar NaOH. So why is it standard? Because you know the concentration, right?
Yeah.
Then here, how much of the NaOH solution was needed? 144.2 milliliters. 142.2 milliliters of this solution was needed to titrate the HCl. By titrating the HCl, I mean completely it reacted,
Completely, yeah.
right? And this much of NaOH was needed. Okay.
Uh,
So that gives you a sense of how many moles of NaOH was needed. No, this volume and
Yeah.
the concentration gives you the moles, right?
Yeah.
Now, ultimately, we have to find identity of mass element M and mass M produced in grams in this reaction. Basically, okay, we'll find everything. So first find out the moles of this. Okay, so this is 144.2 into 0.511. This is milliliter into mole per liter. So it will be millimole. Okay, correct?
Yeah.
So this is the millimoles of HCl that would have reacted with NaOH. No, this is NaOH, but NaOH and HCl will react in equal proportions, right? 1:1 ratio, right?
Yeah. Yeah.
So this is the this is also the millimoles of HCl that was produced in the
HCl.
reaction, right? Correct.
Yeah.
So if HCl was produced this much, then this would be 1/3 of it, this would be 1/2 of it, and this would be 1/3 of it, right?
1/3 of it. Yeah.
And if this was 1/3 of it, then this is 2 same. So this is 1/2 of that. So 1/6 of it, no?
Yeah.
The relation between this and this will be 1/6 of 1/6 of 144.2 into 0.511 millimole, right?
Yeah.
By common sense and following the balanced reactions, right? 2:6, and this is 1:2, right? So it becomes 1/6, right?
Yeah.
Everyone has understood that step, no?
Yeah.
So okay, so this becomes 24 almost. 24 6 are 144, and this is 24 into 0.511 is almost 12, right? I'm not doing it very exactly, but doesn't matter. 12 millimole, okay? 12 millimole weighs 0.855 grams, right?
Yeah.
0.855 grams. So 1 mole weighs 0.855 by 12 into 1000,
1000.
right?
Yeah.
So now this is almost 12 sevens are 84. So 0.7, I will say almost 0.7 into 1000, right? 0.7 nahi na, 0.07 I think. Yeah, 0.07.
Yeah.
Right? Then only you'll get 0.84, no?
Yeah.
So 0.07 into 1000 will become 7 by 100. So 70, right?
Yeah.
70 is approximately the mass of this, molar mass of this, right? So so M2, so 2M plus 48 is equal to 70. So this will become almost 32, right? 22. M is almost 11.
Yeah.
M is 11. 11 is a weird number. So carbon is 12. So 11 will be what? Boron. No, boron. Yeah.
Yeah, boron.
Right? Boron. Okay. So you can check the answer. Like, can you check the answer once? At the end of the book, it will be there. Wait, I will only check. 3.148. 3.148. Okay, it is M2O3. it is boron. Okay, 10.8 is giving. Okay, he has written it is B.
Yeah.
Okay, so
Yeah.
we got that answer. We got approximately, we got 11. No, his answer is 10.8.
Yeah.
Okay, so are you understanding, getting a sense of what is happening?
Yeah.
Right. So he also asked how much metal was produced at the end of this process. So metal was this, right? So it is 1/3
Yeah.
of the moles of this, right?
Yeah.
Whatever moles of HCl was there, 1/3 will be the metal produced, right? So
Yeah.
so 1/3, when you divide by 3, it is 48 into 0.511, right? So it is almost 24 millimoles. 24 millimoles is equal to 1 mole is 70. No, 1 mole is 11 metal, right?
Yeah.
Metal is 1 mole is 11. So 24 millimoles will be 24 by 1000 into 11, right?
11.
So 240, 264 by 1000. So it is 0.26 grams or something. 0.26 grams of metal approximately will be produced. Did you understand how we did it?
Yeah.
Right? Okay, so this meeting will end. Just join the next call also. Okay.
Yeah.